Innovative thinking, responsible technology. At Umbra Applied Technologies, this isn't just a catchphrase, it's a corporate culture that permeates everything we do, based on a set of uncompromising core values that demands we responsibly use our technological resources to protect the lives of our citizens, public servants, and soldiers. Umbra Applied Technologies. Changing the world is what we do. Headquartered in New Jersey, Umbra Applied Technologies, or UAT, is poised to be a global security company that will employ an estimated 10,000 people internationally and will be principally engaged in the research, design, development, manufacture, integration, and sustainment of advanced defense, security, and technology systems, products, and services. In recent times, we have been made more aware of the increasing threat of terrorist acts of violence using concealed weapons and explosives to harm property and people. A number of these attacks have taken place in buildings or on modes of transportation such as airplanes and trains. In addition, the number of mail-bomb terrorist acts has increased dramatically over the past several years. Mail, in the majority of cases, is transported over long distances by air carrier. It has become increasingly more important to interrogate baggage and containers, not only at human ports of entry and departure, such as airports and border crossings, but also at seaports and domestic postal facilities. Another area of great concern to the public and to our government is the high rate of gun and drug traffic into the U.S. The effects of these problems are well known, and the real issue is, how do we impede it? Illegal drugs and weapons enter the U.S. by many means, one of which again is our airports. Other points of entry include border crossings by people and vehicles, and seaports. For the contraband problem, arrivals into the U.S. are of the most interest. To counter these problems, numerous devices, as vapor sniffers, dogs, and X-ray machines have been implemented. Although these devices work to some degree, improvement in the detection of both explosives and illegal drugs is needed. This is indicated by the fact that the number of terrorist incidents and drug-related seizures has not decreased, but has in fact steadily increased, and is at an all-time high. Umbra Applied Technologies, in conjunction with its contractors, will provide the resources to develop improved methods of contraband detection. Under one such effort, Umbra Applied Technologies Group has developed the Contraband Detection and Imaging System, or the Cdis platform, as it is commonly known. The Cdis platform is based on a nuclear phenomenon called Gamma Resonance Absorption, or GRA. GRA relies on the fact that certain elements, such as nitrogen or chlorine, will preferentially absorb gammas, or what are sometimes called photons. If a field of photons is caused to pass harmlessly through a volume of substances, and a suitable photon detector is on the opposite side of the volume being interrogated, then these photons can be used to image a volume and very specifically the presence of key elements, such as nitrogen or chlorine. The presence of these elements in certain quantities is an indicator of contraband. Implementation of the GRA principle-based Cdis platform is highly flexible. Many configurations are possible and can be customized to the client's specific needs. The Cdis platform open architecture design allows for specific designs for each application. Applications include the scanning of vehicles, L3 shipping containers, border entries, perimeters, luggage, cargo, IEDs, and full-body diagnostics, as well as detection configurations for portal, standoff, and remotely monitored or operated systems. One unit can service multiple nodes and generate a 3D tomographic image of a large area of interest. The scanning of total contents with simultaneous imaging by element can be implemented with fully automated decision capability without operator interpretation of image or data. The Cdis system needs minimal maintenance, with hydrogen gas refilling and general inspection occurring once annually. One or more Cdis platforms can be monitored 24 hours a day, 7 days a week, remotely from anywhere in the world. The basic characteristics we have demonstrated allow for the simultaneous inspection of multiple objects for explosives and nuclear materials, capability to define a specific signature for explosives or any other determined contraband, a fully automated decision-making platform with a greater than 95% accuracy rate, a single source that can feed multiple inspection stations over a relatively large area, high throughput due to speed and accuracy. The technology is completely safe and, as a result, has no residual activation or site contamination. Contraband is easily identified and located due to the elemental 3D imaging capability. Monitoring one or more Cdis platforms can be performed from a network operations center or any other command center locally or remotely using existing desktop computer technology. The Cdis platform's accelerator produces a shielded and highly collimated beam of low-energy X-rays, while the target produces only gamma radiation, with no neutrons. The dose to image nitrogen in the human body is 0.026 millirem, while the dose to a stowaway will be considerably lower. The Cdis platform's gamma flux is 2 to 3 orders of magnitude lower than for current vehicle and cargo inspection systems, or CT systems. Umbra Applied Technologies is looking to execute the rapid deployment of resonance technology for detection and imaging of concealed explosives, chemical and biological warfare agents, dirty and nuclear bombs, human and drug trafficking, and any emerging threats, and to begin the design and implementation of gamma resonance technology for medical applications through non-invasive whole-body composition, scanning, and imaging by chemical element. Initial market research has indicated potential users of the Cdis platform. Subsequently, preliminary talks with candidate clients has already begun. The Cdis platform is extremely versatile and highly adaptable. As a result, the Cdis platform can be implemented in many ways, including but not limited to border control, shipping ports, and stadiums hosting events such as the Super Bowl, the U.S. Open, the World Cup, and the Olympics. Airline, rail, and monuments such as the Statue of Liberty, the Eiffel Tower, and the Colosseum in Rome are also areas that would benefit from this platform, as well as postal facilities, embassies, water treatment plants, and power plants. All of these have been identified as highly desirable targets of interest to terrorists. The same gamma resonance technology has medical applications for non-invasive whole-body composition scanning and imaging by chemical element. This technology was introduced at 2 World Whole Body Composition and Imaging conferences held at Brookhaven National Laboratory as the technology of the 2000s. It surpasses CAT scan, MRI, and PET scan in its unique capability to image the human body by chemical element. This technology combines Umbra Applied Technologies' innovative thinking and know-how with magnetic resonance imaging and electron spin resonance, developed by Picker Nordstar, representing Picker, Nycomed, and Instrumentarium. It was later produced by Philips and is currently being used at the National Institute of Health, National Cancer Institute, for early detection of cancer and differentiating cancer cells from normal cells. With the ability to scan and identify anything on the periodic table, a GRA principle-based medical scanner will have unsurpassed scanning capability. For centuries, we have had a need to see inside the human body so that we may sustain and even preserve life. Today, we at UAT are meeting those needs, and as a result, our lives will never be the same. At UAT, we recognize that there is a requirement for new technology to meet the future needs of national security. Configurations for various applications have been explored and presented, from small parcels to large cargo containers. Mobile capability of the system has been indicated. The gamma source, the main obstacle of the past, is at present commercially available. Present objectives are systems integration, prototype certification, and designing a deployable system. UAT's latest world-changing product is revolutionary. UAT has taken the practicality of the GRA principles and combined it with the global needs of many. There is a need for new technology to meet future requirements of not only our own national security, but the security of all nations desirous to live terror-free. Proof of principle of gamma resonance technology for explosive detection and imaging has been proven and demonstrated in lab conditions and is currently being field tested. Gamma resonance technology is a viable method for detection of explosives and other elements in small and large shipping containers, not only at seaports, but while in transit over our roadways. With highly effective and low-maintenance engineering, combined with a life cycle of 10 to 15 years per unit, the Cdis platform is not only efficient, but cost-effective. The proposed Cdis technology fills deficiencies of current X-ray scanners and other systems in use. With the extensive expertise of Umbra Applied Technologies Group and commercially available components in the areas of nuclear physics and particle accelerators, we believe we will have a high degree of success. With the appropriate funding, a test facility ready for systems testing and prototype certification can be delivered within 6 to 12 months, with a field deployable system being developed within 12 to 18 months. Umbra Applied Technologies. Changing the world is what we do.